Assalamualaikum warahmatullahi wabarakatuh. Hello guys, how are you? Today I will presentation about chapter 9 extreme value of function and creating graphic of function, project 4. Okay, let me introduce myself. My name is Nelly Febriani. My student ID number is 21029169. My study program is Mathematics Education, Class A. Okay, first 9.1 a function and then function. Definition 9.1. 1. The function f is said to be increasing on the interval I if for any x1, x2 element interval where x1 is smaller than x2, then fx1 is smaller than fx2. 2. The function f is said to descend on the interval I if for any x1, x2 element interval, then fx1 is greater than fx2. Theorem 9.1. Consider a function that has a derivative on a closed interval ab. 1. If f accent x greater than 0 for every x in AB, then f increase in AB. 2. If f accent smaller than 0 for every x in AB, then f goes down to AB. You can see the figure 9.2 in the illustration in figure 9.2. The function f increases on closed interval x1, x2, x3, x4, and x5, x6. The function f descends on a closed interval x2, x3, and x4, x5. Okay, the second is 9.2 extreme value. Definition 9.2. 1. The function f is said to have a relative maximum value at C if there is an open interval containing C, so that fc bigger is equal to fx for x into interval. 2. A function f is said to have a relative minimum value at C if there is an open interval containing C such that fc is equal to fx for x in the interval. 3. A function f which has a relative maximum or relative minimum at C is said to have a relative extreme at C. Definition 9.3. If f accent C is equal to 0, then the function f is said to be stationary at C. The value of fc is called the stationary value of f. The point C, fc, is called the stationary point of f. Theorem 9.2. If f is definite at AB and has a relative extreme at C, A smaller than C smaller than B, then f accent C is equal to 0 or f accent C does not exist. Okay, you can see the figure 9.5 sketch maximum function and figure 9.6 sketch minimum function. Furthermore, from figures 9.5a and 9.6a, geometrically we can also conclude that if the function f reaches a relative maximum at C, then the graph on the left of point C goes up and on the right C goes down. On the other hand, from figures 9.5b and 9.6b if the function reaches a relative minimum at C. Then the graph on the left of C goes down and the graph on the right goes up. Given this fact and theorem 9.1, we have an extreme dash apparatus known as the first derivative test for relative extreme. Theorem 9.3, first derivative test for relative extreme. Suppose it has a derivative around C, except perhaps in C itself. 1 if f accent x bigger than 0 for x smaller than C, and f accent x is smaller than 0 for C smaller than x. Then the function f has a relative maximum value at C. 2 if for x smaller than C and for C smaller than x, then the function f has a minimum value relative in C. In conclusion, the step for determining the relative extreme of a function f are: 1. Determine f accent x. 2. Determine the critical number of x values. F accent x is equal to 0, or f accent does not exist. 3. Use the first derivative test, or theorem 9.3. Concavity and inflection point. Definition 9.4. The graph of the function f is said to be concave up on the interval I if the graph of f lies above all of its tangent to I. The graph of the function f is said to be concave down on the interval I if the graph of f lies below all of its tangent to I. Theorem 9.4. Concavity test. 1. If f double accent x the bigger than 0 for all x in I, then the graph f is upward sloping at I. 2. If f double accent is smaller than 0 for all x in I, then the graph f is concave down on I. This is an example of concavity. Definition of 9.5. The point P on the curve is called the inflection point if the curve changes from concave up to concave down, or from concave down to concave up in P. Theorem 9.5. If f has a derivative on the interval containing C and CFC is the point term, then f double accent C exists and double accent C is equal to 0. Theorem 9.6. Second derivative test for relative extreme. Suppose f have a derivative on an open interval containing C and f accent C is equal to 0. 1. If f double accent C smaller than 0, then have as a relative maximum value at C. 2. If double accent C is bigger than 0, then f has a relative minimum value at C. 9.3. Absolute extreme on a closed interval. Definition 9.6. Suppose the function f is defined on a closed interval and C is a member of the interval. 1. If fc bigger is equal to fx for all x in the interval, then fc is called to absolute maximum value of f in the interval. 2. If fc smaller is equal to fx for all x in the interval, then fc is called the value of absolute minimum of f in the interval. 3. If fc absolute maximum or absolute minimum, then fc is called the value absolute extreme of f. Theorem 9.7. Extreme value theorem. If it is f continuous in closed interval a, b, then f is absolute maximum and absolute minimum value in a, b. Closed interval method to find the absolute maximum and minimum values of a continuous function f on closed interval a, b. 1. Find the value of f in the critical number f in a, b. 2. Find the value f at the interval boundary point. 3. Compare the value in step 1 and step 2. The latter is absolute maximum value, the smallest is the absolute minimum value. Okay, let's 9.4. Drawing graph of algebraic function. So far we have discussed several aspects of function. Now in turn we are ready to pour this aspect into properly describing graph. We have good lines for sketching the graph of the function y is equal to fx. 1. Origin. 2. Axis intersection. The y-intercept is f0 and we take the x-intercept for y is equal to 0. 3. Asymptote. A. Flat asymptote. The line y is equal to L is a flat asymptote if lim x goes to infinity, fx is equal to L, or lim x goes to minus infinity, fx is equal to L. B. The asymptote is upright. The x is equal to C line is a vertical asymptote. If at less on the limits the following are fulfilled, lim x goes to C minus f x is equal to infinity. Lim x goes to C plus fx is equal to infinity. Lim x goes to C minus fx is equal to minus infinity. Lim x goes to C plus fx is equal to minus infinity. 4. Interval up and down. 5. Extreme values and their types. 6. Concept and inflection point. And 7. Sketch the curve. Okay, thank you for attention and thank you for watching. Do you have any question? You can question me in my Gmail and my Instagram. Wassalamualaikum warahmatullahi wabarakatuh.